Hey, what's happening, guys? I'm sure you recognize this. This is the Arduino Nano, and I've done a ton of videos with them. This one's got a little banged up there. You get these guys for like $3, and they are incredibly useful, but they're getting up there in age a little bit. And now there's something new, something better. So, goodbye to the Arduino, and say hello to our new little friend from the Raspberry Pi company, the Raspberry Pi Pico. There it is. This is the Pico. This is the new $4 microprocessor from Raspberry Pi. And it is pretty cool. It's also pretty small. And look, it even has castellated edges on it so that you can solder it on to your projects without having to use legs. It uses the RP2040 microcontroller. It is a dual-core ARM Cortex M0 processor. Yeah. It has a flexible clock running up to 133 megahertz. It has 264 kilobytes of on-chip RAM, 2 megabytes of onboard flash. It has 26 multifunction GPIO pins, including 3 analog inputs. It has 2 UARTs, 2 SPI, 2 I2C, 16 PWM channels. It has USB 1.1 PHY for host and device support. It has 8 programmable state machines to support the pins. If you don't know what that means that is separating the microcontroller that is doing the logic of the program from controlling the pins. And that makes things a lot smoother and a lot faster. It works from 1.8 to 5.5 volts DC. It has drag and drop programming, which I think is incredibly cool. Low power sleep dormant modes. It has an on-chip clock and a built-in temperature sensor. So that's pretty cool. I bought this from Adafruit for $4 plus shipping, so $10 in all. It's come with some legs. Let's solder some legs on this and see what we can do with the new Raspberry Pi Pico. I always like to solder the legs in with whatever I'm using in a breadboard. That way, when you pull it out, you know it's going to fit back in perfectly. So if we take this out, you can see the legs are nice and parallel. And we can see the pin names there. VBus, VSystem, ground, 3.3 volt, ADC, VREF, GP28, A ground. Now the Raspberry Pi Foundation has a wonderful website. If you just type in Google search Raspberry Pi Pico, it'll take you right to it. It'll give you an excellent PDF of the chip and what all the pins and everything means. So let's see if we can hook this up and do the official hello world for the microcontroller, which is, of course, the blinking LED. Okay, so we're looking at the raspberrypi.org/documentation/pico/getting started website, and I'll put a link to that down below. Come down here. Talks about we have the board specifications. And if we look in here, we can see all of our pins, GPIOs. Where is GPIO 25, which is what I believe the LED is on. So GPIO 1, 0, 1, 2, 3, 4, 5. Lots of grounds. 16, 16, 17, 18, 19, 20, 21, 22, 26, 27, 28. I am not seeing 25. It's like they didn't put a an output to it on here. 3 VSys VBus. And if we look over here, we can see we have UART 0, TX, and RX. Oh, is that UART 1? No, that's UART 0. Over here we also have it. That's interesting. We have our SDA, SCL. That's our SPI interface there. I2C interfaces. So we got a lot of interfaces here. Lots of good stuff. What I am looking for now is the Raspberry Pi file that we need. So you need to start with MicroPython. We need to download the UF2 file. So let's get that rolling. Okay, we got it. Let's find it in the folder. Downloads MicroPython F2. Okay, good. So it's there. What do? We've downloaded it. We're going to push and hold the boot select button and plug your Pico into the port of the computer. Release the boot selection button after your Pico is connected. It will mount as a mass storage device called RPI RP-2. Drag and drop the UF2 file in there. Your Pico will reboot. You are now running MicroPython. Okay. Let's do that. Sorry you're not going to be able to see, but you should be able to tell if it connects. Alright, I am holding... Whoops! I almost knocked my microphone over. I am holding the boot select button, and I'm going to plug in the Raspberry Pi Pico. Then I'm letting go of it, and there it is, right there. Let's see what this web page is. Oh, it just took us right back there. Okay, well that's cool. So, info to text. So now here's our Raspberry Pi 2. So if I go to downloads, the UF2 file here, drag and drop it down into here. I don't see the Raspberry Pi anymore. I hope that's what was supposed to happen. I am now running MicroPython. Okay, so the next step is we are going to break open the IDE, which is the Thonny IDE I downloaded, and I will put a link to that down below as well. Alright, so I've installed the Thonny IDE. Hopefully we can get it running. Thonny, okay. Let's see what we get. English Standard, let's go. File tools, edit, view, run. Manage plugins. Whoops. See what kind of options we have here. Okay, interpreter, run and debug. Well, I really don't know anything about MicroPython. So let's put in the simple hello world program. It shouldn't be too hard for us to do this. So we say include Pico /std lib.h. Alright. Let's skip a line. Then we have int main and some curly brackets. And we create a constant, the uint type, called led underscore pin equals 25. It gets a semicolon. Then we say GPIO underscore init led underscore pin, and that also gets a semicolon. Then we have a GPIO, that stands for general purpose input output underscore set direction led underscore pin comma space GPIO underscore out. So apparently that we were making it an output. And then we say while true, another curly bracket, GPIO underscore put, that must be how we address the pin, yeah, put LED underscore pin comma 1, which would be the Arduino equivalent of setting it high. Then we say sleep underscore milliseconds 250, so that's a quarter of a second, semicolon, and then we say GPIO underscore put LED underscore pin comma 0. It's like we missed a space here. There we go. Comma 0 semicolon. Then we say sleep underscore milliseconds 250 semicolon. Then we have close that curly bracket, and we close that curly bracket, and hopefully that's our program. We got here debug, run current script, save, open. What happens if we run it? Now it wants us to save it. Okay, let's call it first blink. Line 3, Python doesn't know how to read your program. Okay. Line 3, int main. I am confused. I will return when I am less confused. Okay, after a little bit of research, I figured out you need to click down here on the version and set it to Raspberry Pi Pico. So now we are in the REPL shell, which is what read, evaluate, print, list, I think. So if I say print hello, hit enter, it says hello. So now we should be able to write our program here. Okay. Now I'm going to put up a little window here so you can see the thing. And let's try this again. File, run the current script. File, STD. So it still doesn't like that. Okay. Let's go over to this lovely help file. And it says we should be able to put this into our REPL. Hit enter. Yes, our LED has lit up. So now, if I do that again, and this time say 0, whoops, dangnabbit. Bear with me a second here. And our LED has gone off. So we are communicating with the thing. Good. So going back to our help, click on the main editor page. In this step, program. Okay. So let's grab this little program here. And we'll kill all of this crap. Put that in there. We click run. Do we want to run it on the computer or the Python device? We want to run it on the Python device. Run. Run current script. Is she blinking? No, not particularly. Perhaps that's because I haven't saved it to the Python. Okay, let's do this. Let's get out of here. Let's rerun Thonny. Why isn't it letting me save it? Save as Raspberry Pi Pico. Okay. Name, what is called Blinky. Alright, can we run it now? Oh, so it's gone off. Maybe if I run it again, does it go back on? Yes. Okay. Perhaps I should read along further in the instructions. One moment, please. No, can't do that. Okay. Okay. You need to enter Blink Pi as a file name. Oh, okay. Each time you click the run, but you can use the timer. Alright, let's try this. We'll call this one. I am totally new to this, so don't give me some bunch of crap. You don't know what you're doing. I know I don't know what I'm doing. I'm a hardware guy, not a software guy. Alright, we'll save as to the Pico. We'll call this one Blinky2.py. And we'll run it. Finally, we blink. So obviously I'm going to have to learn some Python. Yeah, I don't know about you guys, but I'm kind of excited by this. This seems like a really way more powerful device than the Arduino. So I have one question. Where the heck is that pin? Okay, so as I'm looking at it, I think that pin there on that end is GPIO 25. I'm going to have to move this. Get out of here. I'm going to unplug it just so I don't short anything out. Doesn't say anything. Let's plug her in down here, just so I have more room. Oh. Come on. There we go. Okay, that's in. Let's plug this back in. So it does not automatically start to run the program. Okay. So I should be able to bring Thawny back up. And file, recent files. Open the Pico, Blinky Pi, and run it. Are we blinking? Okay, we're blinking. So what I've got here, I'm going to zoom out a little bit so you can see more what I'm doing, is a 10 millimeter LED. I should be able to plug this into here, if that is in fact pin 25, which I think it is. And then we should be able to hook up a ground here. And I believe the third pin here is a ground. No, that's certainly not doing anything. 1, 2, 3. Did I put that in backwards? Nope. Is it this one instead of that one? Nope. Are we not making a connection? Nope. Alright. Any of these do anything? We're not getting anything there. I don't know. Okay. There does not appear to be a way to link up to pin 25, which is the onboard LED. So this one down here is pin 15, which is what I linked to, and then I just crossed it over here to the ground, which is on that third pin from the top. Obviously, there's a lot more to learn. I intend to do that, and I hope that you will join me. I think this board has a lot of potential. Next time we are going to investigate the onboard temperature sensor. So I hope you liked this video. If you did, please give me a thumbs up. Feel free to comment and share, and don't forget to subscribe. Big thanks to all the patrons. That's it. I'm out. Peace.